In 8.5, we are talking about inference. So you are either going to reject or fail to reject a null hypothesis. We're still playing the same game. This time, though, we have two samples. So we're going to have P1 and P2. We're still working with proportions. Our null hypothesis is going to be that these two proportions are equal to each other, that there's no difference between the two values. Or if you were to find a difference, another way of saying this is that P1 minus P2 is 0. The difference between the two is 0. There's no difference. They're the same. The proportion of success for dataset 1 and dataset 2 are the same. Taking a look at this, we're going to have different sample sizes. We're going to have different values for P, one for each data set, and we're going to have different values for Q. Our null hypothesis is that the proportion of success of both data sets are the same, or P1 minus P2 equals 0. There is no difference. If P1 has a probability of success of 18, and P2 has a probability of success of 18, then P1 minus P2 equals 0. There's no difference. This is our null hypothesis. Everybody's the same. The alternative hypothesis is that they're not the same. Either P1 is less than P2, and if you have that situation, you will end up with a negative value. P1 is greater than P2, so when you subtract them, you get a positive value. Or we don't know. We don't know if one's bigger than the other, or one's smaller than the other. We don't know if it's greater than or less than. We just know that they're different. And so we're going to do the not equal to. And again, this will be two-tailed. Two-tailed. So you're going to have to find the area under two tails. We're going to have a threshold, 1%, 5%, 10%, or some other value that they give you. And away we go. These are the calculations that the spreadsheet's going to do for you. So how do you find this new value called P bar? Well, you got to take the sum of the successes and divide it by the sum of the trials. That'll give you P bar. To find Q bar, you just subtract P bar from 1. So it's a complement, sort of an idea we've seen before. You then take these values and you get a Z-score by doing this. So you plug in these numbers, you get a Z-score. From that Z-score, you will then find a P value, area under the tail, where the tail is the Z-score, right? The target is that Z-score. Once you have that, you compare it to the threshold and you either reject or you fail to reject the null hypothesis. Test the claim that the proportion of men who own cats is smaller than, okay, so that's a red flag, right? Smaller than means less than. That means left-tailed. That means we're looking for the area to the left of a target. So that word is key. You got to pick up on that. The proportion of men who own cats is smaller than the proportion of women who own cats at the 1% significance level. Okay, so I'm going to clear out my data here. I do know that's going to be 0.01, so I'll type that in right now. So there's my significance level. So let's look at this. Now, again, we are dealing with proportions, P's. We're not dealing with mu's. We're not dealing with the mean of a data set. So anything that has a mu in it, immediately discard. So the null, of course, is that they're equal. There's no difference between the proportion of men who own cats and the proportion of women who own cats. They're the same. Nothing's different. That's the null. And our alternative is, no. We think that fewer men own cats, that the proportion of men is fewer than the proportion of women who own cats. And that's where the less than comes in right there. So this is the one that we want. They're equal in the null and they're less than in the alternative. Okay, looks good. Less than means this is left-tailed. There you go, done. That one's pretty easy too. And now here's the data. Based on a sample of 40 men, okay, we got it. 40 men, 25% own cats. So they're kind of giving me the P value. They're telling me P is 25% for the men. What number do I need to put on top here so that way my P value is 25? What number divided by 40 is 0.25? 25%, 0.25 of multiply by 40. What's 25% of 40? 25% of 40 is 10. So we got that. So we're going to drop that in. Okay. Now let's go to the women. So again, we've sampled 60 women. So we'll put that in as our denominator. And then in the numerator, we need 30% of that. So one quick way to do that is to say 10% of 60 is 6. And then If 10% is 6, then 30% has to be 18. And so 18 out of 60. And there you go. There's your 0.3. Now, again, if you can't do that, then you're going to say, we need to find 30%, 0.3 of 60. And it's 18. Here is our 0.25. Here's our 0.30. It appears that the proportion of men is less than the proportion of women. I've got 25% of the men and 30% of the women. So it looks like initially that, yeah, it's a lower number. But could our samples be biased? Could we have accidentally sampled a group of men that for some reason they're not allowed to own cats and that's why they don't have them or something? Or could we have accidentally surveyed a group of women that were all part of the cat owner club and we didn't know it? Is there an inherent bias in our sampling? How likely is it that if we went out and resampled 40 men, that 10 of them would own cats? That's what we're getting at. So it's not just P and Q and say, oh, yep, there, we're done. The sample size matters. The bias built into our sampling matters. And we have to account for that. That's why we're doing the normal distributions and the thresholds. So our significance level is at 1%. Our confidence level is 99. Here's P bar, here's Q bar. And then this is the number that you want. Here's our test statistic. So we're going to copy this and we're going to paste it right there. We're going to round this to 2 decimals. If you wanted a diagram of this, once again, you should be able to do this. And remember, our null hypothesis is that there is no difference between them. The proportion of the men minus the proportion of the females is equal to 0. P sub M is less than P sub F, which means when you do the subtraction, you should get a negative number. So our value over here, when we subtract these, should be a negative number. And we are looking for the area to the left of that negative number. What is this P value and how does it compare to our 1% threshold? Our P value is this. Copy, paste. 0.29, 29%. 29% is the area under this curve. Actually, my graph should probably look like this. If it's 29, I got to add some area in there, right? It's going to look something more like this graph, right? 29% is a lot of area. So did we come in under our threshold? No way. We are way over. We foot faulted huge on this threshold. So that means we do not reject the null hypothesis. The null hypothesis that there's no difference between the two stands. Yeah, but look at it's 0.25 and it's but doesn't matter. We had a biased sample. We need to go back and redo this. And let me drop these numbers in and make it green. Hopefully it turns green and hopefully we got this right. Yeah, there we go. At first glance, looking at just the straight proportions, it looks like there's a 5% difference between the two, right? The females that own cats are at 30%. The males that own cats are at 25%. Clearly, there is a huge difference between these two. Not so fast. And so there's not enough evidence here to suggest fewer men own cats. We do not reject the null hypothesis that the difference between the two is equal to 0.